So here we have a triangle with center at C, and we have the diameter of the circle. Now in this case, the endpoints of the diameter are given. So let's say this endpoint is A, its coordinate being x1, y1. And then we have the other endpoint of the diameter denoted by B with coordinate x2, y2. Now, the goal will be to determine the equation of the circle if we only have the endpoints of the diameter given to us. For this, what we'll do, we'll consider one half of the semicircle. So for simplicity, let's consider the upper semicircle. Here we're going to consider a point, and let's call it D, and this point D has a coordinate x, y. It could be anywhere on the semicircle. And now what we'll do construction. We will join point A and point D, and we'll also join point D and point B. By the laws of geometry, we can say that AD will be perpendicular to BD, or we can say that this angle ADB is going to be 90 degrees. Now, what we'll do, we'll try to find out the slope of AD. So slope of AD, so that will be given by, so all we have to do is take the ratio. In the numerator, we'll take the difference of the y coordinate, so we'll take y minus y1, and in the denominator we have the difference of the x coordinate, so that's x minus x1. Let's call it m1, and let this be equation number 1. Then we'll also find out the slope of the line BD. So slope of line BD will be y minus y2 divided by x minus x2. So let's call it m2. Let this be number 2. Now we know for a fact that whenever we have two lines perpendicular to each other, then the product of their slopes is going to be equals to -1, meaning we have m1 times m2, so that will be always equals to -1. So we can rewrite it as in place of m1 we have y minus y1 divided by x minus x1, all multiplied to m2. So m2 is y minus y2 divided by x minus x2 equals to -1. So if we first simplify this, then we're going to get x minus x1 times x minus x2 plus y minus y1 times y minus y2. And this actually gives us the equation of a circle. So this is the equation of the circle when we have the information regarding the endpoints of the diameter. Fine. So if we want, there is another way, there is another form. So all we have to do is expand this. So when we expand it, we're going to get x squared plus y squared minus x1 plus x2 times x minus y1 plus y2 times x plus x1 times x2 plus y1 times y2. So this is nothing but the expansion of this particular equation. The reason why we've written in this particular fashion. Now we can use the general form of the circle. We know that the general form of the circle is given by x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Now if we compare this, we can find out the value of g. So g comes out to be negative of x1 plus x2 over 2, and f comes out to be y1 plus y2 over 2, and this entire value will be negative. And we can also find out the value of c, so that's simply x1 x2 plus y1 y2. This will become useful in some other case, but we'll stick to this particular formula. So this is going to be the equation of the circle when the endpoints of the diameter are given to us, or another way, this is the diameter form of a circle. Let's try to understand this with the help of few problems. Problem number 1. Here we need to determine the equation of the circle whose endpoints of the diameter are given to us. So here, let's say x1, y1. So this corresponds to the point -1, 2, and we have x2, y2. So that corresponds to the point 4, -3. So from here, this information, we can find out the value of x1. So x1 corresponds to -1, and y1 corresponds to +2. And then we have x2 corresponding to 4 and y2 corresponding to -3. Now, using the diameter form of the circle, which is x minus x1 times x minus x2 plus y minus y1 times y minus y2. So this gives the equation of the circle. All we have to do is substitute the value of x1, x2 and y1, y2 with their respective values. So we get x minus x1. So x1 here is negative 1. So we get x plus 1 multiplied to x minus x2. So we have x minus x2 is 4. Added to y minus y1. So y1 is 2. Times y minus y2. y2 is negative 3. So where y plus 3 equals to 0. So this is the diameter form of the circle, or we can say this is the equation of the circle. Now, if we want, we can also expand this. So we can use the expanded form. So that's simply x squared plus y squared minus, all we have to do is find out the sum x1 plus x2. So x1 plus x2, that's negative 1 plus 4, so that gives us positive 3. So this will be negative 3 times x. Then we need to find out the sum of y1 and y2. So y1 plus y2 will be 2 minus 3, so that's negative 1. So we have negative of negative 1 y added to, then we need to find out the product x1 times x2 and add it to the product y1 and y2. So x1 is negative 1 and x2 is 4. So we have negative 4 plus 2 times negative 3, so that's negative 6. So we have negative 4, negative 6, which gives us negative 10. So this is going to be negative 10 equals to 0, or we can further simplify it, and this is finally going to give us the equation of the circle, x squared plus y squared minus 3x plus y minus 10 equals to 0. So this is the equation of the circle, and we have obtained it by using the endpoints of the diameter. Let's go to the next problem. So in problem number 2, we need to determine the equation of the circle such that its diameter lies on the intercept formed by the line 2x plus 3y equals to 6 with the coordinate x. Let's first try to understand it. So we have the line. We'll start out with the given equation of the line. So we have 2x plus 3y equals to 6. What we'll do? We'll divide throughout with 6. So we have 2x over 6, so that becomes x over 3. Plus we have 3y over 6, so that gives us y over 2 equals to 1. Let's call it number 1. Now this is the intercept form of the line. So the intercept form of the line is given by x over a plus y over b equals to 1. Now here, a represents the x-intercept and y, the b value represents the y-intercept. Now that we know what the x-intercept and the y-intercept is, so from here we can find out the value of a. So a will be equals to 3 and b will be equals to 2. So our x-intercept is 3 and the y-intercept is 2. So let's try to plot this on a Cartesian plane. So here we have a Cartesian plane, and it's clearly given here that the x-intercept is going to be 3 and the y-intercept is going to be 2. So that means this particular point, which corresponds to B, it is going to have a coordinate 0, 2. Its y-intercept is 2 units, and the x-intercept, let's denote it by A, so that will be 3, 0. Now what we have to do is we'll join the two intercepts to form the straight line. The question is telling us to find out the equation of the circle whose diameter lies on the intercept, meaning AB is going to be the diameter of the circle. So we'll have to draw a circle in such a way that the diameter corresponds to AB. So that means what? We are provided a circle and the diameter's endpoints are given to us. So the endpoints of the diameter are, so we have point A with coordinate 3, 0. So this corresponds to, let's say, x1, y1. And we have point B with the value 0, 2. So this corresponds to x2, y2. So we can use the standard form. So we have x minus x1. So x1 corresponds to 3. Multiplied to x minus x2. So x2 value is 0. Plus y minus y1. So y1 is 0. Times y minus y2. So y2 is 2. So that's equals to 0. And if we further simplify it, we're going to get x squared plus y squared minus 3x minus 2y equals to 0. So this is going to be the equation of the circle with the condition that the diameter of the circle lies on the intercept formed by the line 2x plus 3y equals to 6. Now let's move on to the next problem. Problem number 3. We need to determine the equations of the circle that have the diameters along the diagonal of the rectangle with sides defined by the equation x equals to 6, x equals to negative 3, y equals to 3, and y equals to negative 1. Let's try to understand it graphically first. So here we have our Cartesian plane with the x and the y axis. So let's first try to sketch the line x equals to 6. So the line x equals to 6 is to pass through x equals to 6. So we have 1, 2, 3, 4, 5, 6. So our line is going to be parallel to the y-axis and is going to pass through the point x equals to 6. So this is going to be the line x equals to 6. Then we try to sketch the other line x equals to negative 3. So it's also going to be a straight line parallel to the y-axis, but this time it's going to pass through the point x equals to negative 3. So we have a line x equals to negative 3. Now coming to the next line y equals to 3. So here we have to go 3 units along the y-axis from the origin. So we have 1, 2, 3. Now the line y equals to 3 is going to be a straight line parallel to the x-axis and passing through the point y equals to 3. So here this is the line with equation y equals to 3. And finally we have to find out the line y equals to negative 1. So this is going to pass through y equals to negative 1. So this is going to be a line y equals to negative 1. So here we obtained a rectangle. So let's name the vertices. So the vertices is going to be A. Then we have the vertices given by B. This is the point B is where the line x equals to 6 and y equals to 3 intersects. Then we have the other vertices at C. So this is where the line x equals to 6 and y equals to negative 1 intersects. And then we have the fourth vertex D, and this is the point where the line y equals to negative 1 and x equals to negative 3 intersects. So now we have the rectangle A, B, C, and D. Fine. Now that we have the rectangle, our goal will be to find out, the next task will be to find out the coordinate of the vertices. So this is our rectangle A, B, C, and D. Fine. So that's very simple. To find out the coordinate of point A, all you have to do is find out the intersection of line y equals to 3 and x equals to negative 3. So that means simply the x coordinate is going to be negative 3 and the y coordinate is going to be positive 3. Fine. Then to find out the coordinate of point B, we need the line x equals to 6, so that corresponds to the x coordinate, and y equals to 3, so that is going to give us the y coordinate. So 6, 3 is going to be the coordinate of point B. Then coming to point C, so this will correspond to an x coordinate of 6 units and y coordinate of negative 1 unit. And finally D, the coordinate is going to be, so this corresponds to x equals to negative 3 and y equals to negative 1. So now we have obtained the rectangle with all the coordinate points of the vertices A, B, C, and D. Now the next task will be to find out the equation of the circle that have the diameters along the diagonals. Meaning, so let's say we join A and C. So this is going to be the diagonal of the rectangle, and using this diameter, if we draw a circle, so let's say this is the circle, then our goal will be to find out the equation of this particular circle. So let's do that. So we have the diameter AC. So corresponding to this, all we need is the endpoint. So A corresponds to negative 3, 3, and C corresponds to the point 6, negative 1. We can very easily find out the equation of the circle. So let's do that. So we're going to get x minus x1. So that is going to be positive 3 multiplied to x minus 6 plus y minus 3 times y plus 1 equals to 0. So if we expand it, we're going to get x squared plus y squared. So we need negative of x1 plus x2. So we have negative 3 plus 6. So that's going to be positive 3x. So we get negative 3x. And then we have negative 2y minus 21 equals to 0. So this is going to be the equation of the circle with diameter AC. Next, we also need to find out the equation of the circle having diameter BD. So let's find out BD has 6, 3. So our B is 6, 3, and then we have D, and D has the coordinate negative 3, negative 1. So this corresponds to the diameter BD. Now let's try to find out the equation of this circle. We have x minus x1 times x minus x2. So x2 being negative, we have x plus 3 plus y minus y1 times y minus y2. equals to 0. Or we get simply x squared plus y squared minus 3x minus 2y minus 21 equals to 0. So this is also going to give us a circle with the same equation. Fine. So let's go to the next problem. Problem number 4. So here we need to find out the equation of the circle with the diameter formed by 2 points A and B. Now, the 2 points, the abscissors and the ordinates of the point A and B, they correspond to the roots of two quadratic equations. So, using this information, let's try to find out the equation of a circle. So, let us begin. So, we'll first consider the point A and B to have coordinates. Let x1, y1 and x2, y2. So, these are the points, coordinate points of A and B respectively. Now, abscissor means the x coordinate. So it's given that the x coordinates of point A and point B are the roots of this equation. So it's given here that x1 and x2 are the roots of the quadratic equation ax squared plus bx plus c equals to 0. And we are also given that the ordinate, that means the y coordinate of the 2 points, are the roots of the other quadratic equation a prime y squared plus b prime y plus c prime equals to 0. Now this is given to us. Using this information, we need to find out the equation of a circle. Now coming to the first quadratic equation, so we have ax squared plus bx plus c equals to 0. Now from this, we can easily find out the sum of roots. What is the sum of roots? The sum of roots, since x1 and x2 are the roots of the given quadratic equation, the sum of the roots x1 plus x2, so that's going to be equals to negative b over a. So that's a standard formula. Then we also have the product of roots. Roots, that will be x1 times x2, so that's equals to positive c over a. Similarly, if we consider the other quadratic equation a prime y square plus b prime y plus c prime equals to 0. So here if we consider the sum of roots, the sum of roots will then be, what are the roots of this given quadratic equation? x1, y1 and y2. So we have y1 added to y2, that's going to be equals to negative b prime over a prime. And then we have the product. So the product of the roots, that's going to be product of roots. So that's going to be simply y1 times y2. So that will be equals to positive c prime over a prime. Fine. So now we have successfully obtained the sum of roots for each case as well as the product of roots. Now we have to find out the equation of the circle. Now what's the equation of the circle? If the diameter form is known to us, so we'll use the other form. So we know that that is x squared plus y squared minus x1 plus x2 times x minus y1 plus y2 times y plus x1 times x2 plus y1 times y2. So that will be equals to 0. So this is the equation of the circle. All we have to do is now substitute the values. We get x squared plus y squared minus negative b over a times x minus y1 plus y2 will be negative b prime over a prime times y plus x1 times x2, that's c over a, plus y1 times y2, that's c prime over a prime. So this is the required equation of the circle. But what to do? We'll further simplify this. We're going to multiply throughout with a times a prime. So that's going to give us a prime multiplied to x squared plus y squared plus bx times a prime plus b prime times a times y plus c times a prime plus c prime times a equals to 0. So this is the required equation of a circle. Let's move on to the next problem. Problem number 5. We need to find out the equation of a circle which has a given chord or as its diameter, and the equation of the diameter is given to us, that's y equals to 2x, and the circle to which this is the chord the equation of that particular circle is also provided to us. Meaning, let's try to understand it graphically first. So let's say we have a circle, and the circle has an equation x squared plus y squared equals to 10x. Now, there is a chord that is given to us. The chord has an equation y equals to 2x. This is given to us. Now, using this chord as the diameter, we have to find out the equation of a new circle. That this chord is actually the diameter of another circle, and we need to find out its equation. So how do we do that? All we have to do is find out the coordinates of the endpoints of the chord that will become the coordinates of the endpoints of the diameter. So let's do that. So we have the equation of a circle given by x squared plus y squared minus 10x equals to 0. So let this be number 1. And we have the equation of the chord, which is y equals to 2x. So if we solve the two equations 1 and 2, this is going to give us the coordinate of the endpoints of the chord. So let's do that. So we'll start with equation number 1. All we have to do is replace the value of y with 2x. So we're going to get 2x whole squared minus 10x equals to 0. We get x squared plus 4x squared minus 10x equals to 0. Or 5x squared minus 10x equals to 0. We'll take 5x as the common factor. So we have x minus 2 equals to 0. So solving for the value of x, we get x equals to 0, or we get x equals to 2. So we're getting two values. So let's use the first value. So whenever x equals to 0, then y value is going to be also 0, because we have y equals to 2x, so 2 times 0 will be equals to 0. So this corresponds to the coordinate point 0, 0. So let's call it A. Next, we're going to consider the point x equals to 2. Then when x equals to 2, then y will be equals to 2 times 2, so that's equals to 4. So we get the other end of the chord, so that's 2, 4. Now we have the chord AB. So this is the chord of the circle that's given to us. So point A has the coordinate 0, 0, and point B has the coordinate 2, 4. Now we'll consider that this chord is the diameter of a new circle. So the equation of the new circle, so that's going to be equals to, we have x minus 0 times x minus 2 plus y minus 0 times y minus 4 equals to 0. That's it. This is the equation of our circle. And if we expand it, we're going to get x squared plus y squared minus 2x minus 4y equals to 0. So we have successfully obtained the equation of the circle, and this is how we can use the diameter form of a circle to find out the equation of a circle.